we'll get started. So hello and welcome everyone to this Embedded Android in Real Life session at the live embedded event. I'm Gary Bisson and I'm glad to be here today to talk about Android. First, a quick presentation of myself. I've been involved in embedded software development for some time now. I've worked in different industries, from video games to set-top boxes to consumer and industrial. And while I was writing this presentation, I realized that I've been playing with Android for 10 years now. I started 10 years ago with Android 2.3, also called Gingerbread, on the TI SoC. And since then, I've been using every version of Android, except for 12. The beta came out a few weeks ago, and I haven't had time to play with it yet, but it's on my to-do list. Also, I've used it on different mini SoCs, so from NXP, mainly NXP and Qualcomm, but I've also used Android on other platforms like TI and Atmel. And I'm now working at Boundary Devices. What we do there is that we design single board computers and system on modules, and we also manufacture them. And we're specialized in NXP i.MX SoCs right now. And also note that I don't only do Android development. I'm not a full-on Android fanboy. I also do, I would say, half and half Linux development. And so that's why I contribute to the Buildroot project, the Octo project, a little bit of Linux and U-Boot. I also said that I contributed to the AOSP, but that's a little bit of a brag because I think I only have one patch there. So enough about me. Let's have a look at the agenda. First, we'll do a quick overview of Android. Then we'll see how can Android be a good match for embedded projects with a non-exhaustive list of pros and cons. Also, I'll discuss the most frequently asked questions that we have from our customers. And finally, we'll see some real-life case studies, as well as a live demo, as this is the live embedded event. What can go wrong with doing a live demo at the end? If you have any questions, feel free to ask them on the chat or on the Slack track 4. So let's start with some simple questions. What is Android and why are we here? So the OS doesn't need any introduction anymore, as this is the most used mobile OS nowadays. It is up to 70+% of market share as of 2 months ago. But really what contributed to this, to the popularity of that OS, I think, is the fact that it is open source with the Android open source project, which I will refer to as AOSP. And that's thanks to that openness that the OS got traction across vendors and industry. Note, however, that this isn't a regular open source project, as it is developed behind closed doors. It means that Google provides its source on release dates, but in between releases, it's hard to know what features will come up. There is actually a Gerrit website that you can see. There is a public one and a private one. So on the public one, you can see some of the features that are going to be hitting the master branch, but you don't have access to the private Google Gerrit, where they do most of the work there. And also, Google doesn't open source its own proprietary applications like YouTube or Play Store. So the AOSP experience is pretty bare compared to Android as you know it on your phone. Although it's clearly used in the mobile space, it's not getting as much adoption in the embedded space. So we'll try to see the reason why and why not, because it's not only a shiny UI, it also brings a lot of different features like security and management and so on. Okay. And also, a few disclaimers. I'm not trying to convince everyone in this session that Android is the right OS for every embedded project. It is not. Here I'm trying to show the benefits of using Android and when you should not definitely use Android. Because it's important to say that, because really choosing the OS for your project is the main task at the beginning. And it depends on many different factors that could be actually like a presentation on its own. Like it depends on if your project is an evolution of an existing project. What is your team familiar with as OS and development, and what are your hardware constraints? So that is the question you need to ask yourself before considering Android. And so the goal of that presentation is to give some pointer as to when Android is a good fit. And finally, since this is for the embedded space, the presentation is only about the AOSP side of it. Like I will not cover all the Google specific aspects, like the Google Mobile Services, GMS, or GTS, Google Test Suite, and so on. Now, let's look at the Android architecture. So the main thing you're going to hear when comparing other Linux OSs is that Android is also based on the Linux kernel. And that is great for many reasons, and especially since like the Linux kernel has so many architecture support and so many drivers included. But then Android used to have like a lot of different patches on top of the regular Android Linux kernel. Now this patch set is reducing a bit because Google has been trying to include and upstream as much work as possible. And even some people have been able to boot Android using a mainline kernel, but there are still a few patches laying around that you need to be able to boot Android. But mainly it's the Linux kernel as you know it. And then on top of that Linux kernel, everything else basically has been redesigned. Most of the key component of an OS, as you know it, and the Linux OS is different. So starting with the C library. So the C library is not glibc or any other C library that you would know in Linux. It is the Bionic C library. Same for the init process. It doesn't use systemd or any like CSV init and stuff like that. It doesn't use that. It uses its own init process. Same for the inter-process communication. It uses something called binder. And most of those choices were made at the time for licenses purposes, trying to avoid the GPL license as much as possible. So most of those are under like BSD or Apache licenses. And then you also have like all the system server and native services that have been created from scratch by Google, along with the Java UI frameworks. And also they created that hardware abstraction layer to be able to interface like any type of hardware to those native services and Java frameworks. Yet, also know that Android still relies on many open source projects. It's mainly the core, like as I said, like the init process, the IPC, and the framework that have been rewritten. But there are a lot of existing open source projects that are used as is. Good examples are WPA Supplicant for the Wi-Fi or Toybox. But so that is another example. But then you also have like some custom partition and file system layout. So this is not using the following the file system hierarchy standard. So you won't find any /user/bin, /user/local and stuff like that. That is different in Android. Instead, everything has been split into different partitions like vendor, system, OEM. And also, this partition layout is different whether you use AB or non-AB devices. We're gonna cover like what are the differences later on. But yeah, and they're still trying to improve their layout and to add new features. And that's why like in latest version, they also added something called the super partition, where you can do dynamic partitioning. And this is a good example of something that is very Android specific. And the same goes for the custom build system. It doesn't use anything that has been used before. I mean, at first it was a Makefile based, and now it's using the song build system with Android.bp, so blueprints. And then at the end, it uses the Ninja tool to build all the different components of the system. So even the build system is different from what you would see in Linux OS. Then one key difference is the security, where it started with mainly application sandbox and signature. So the application sandbox has always been there in Android. So it was basically having the application running as its own user in its own sandbox, and having signatures to make sure that every application has been verified. And also, like, this signature allows you to have access to some specific API if you, for instance, sign with the platform key. Then they added SC Linux. So SC Linux is not Android specific. It's something you can enable on the Linux system. It defines an access control for the processes and files. And the good thing with Android is that they already did all the groundwork for you. Like SC Linux is already there. There are already like rules for pretty much everything. They've already added rules to make sure that a regular application cannot access device nodes and stuff like that. You know, so really, like SC Linux, I don't remember like when it was added, but it was now like some time ago. And it's still improving every release, but it's a good addition in terms of security. Then they also added the trusted environment execution, which is on ARM system using trust zone. And so here what they provided is that, and it's what is rare on those OSs, is that they provide like a standard implementation on how to run certain application in the trust zone. So basically in Android, you usually have at least 3 different applications, which is the key master, which takes care of managing your keys and stuff like that, the gatekeeper, and AVB for everything related to the Android verified boot, which we'll see in the next slide. Oh, I have one question. Okay, yeah. So for the automotive industry, I'm gonna try to talk about that a little bit later. Also, so we've talked about the security, the general architecture, and let's have a look at the boot process. And even the boot process itself is very Android specific, because usually on a Linux system, you have a bootloader, or a bootloader that loads the kernel, device tree if there is one, and the RAM disk if there is one, and then jump to it. In Android, it's still the same, but they package it in different images that are Android specific. So they do have a boot image that includes the kernel, the device tree, and the RAM disk. Now they also do have a DTBO image for all the device tree overlays. The idea is that your boot image could be used, you could have like a generic boot image, and then the DTBO image would be the one that would pick the different overlays for your specific hardware. Then they also added something called the boot control block to have communication between the OS and the bootloader. And so all of the above, one quick note about that is that there is partial support in U-boot for all of that. So if you use a standard U-boot, you can communicate and you can read the boot control block. You can boot a boot image. You can manage a DTBO image, and so on. So this is included in U-boot. And then you have the Android verified boot, which uses the DM verity feature of the kernel to check the file system integrity. So basically what it does is that it checks the hashes of the different file system and compare it to what they had at boot up. So the hashes are usually stored into the VB meta partition, and so when booting up, the bootloader will check if the boot image has the right hash against the VB meta, and then once the boot image is loaded and tries to load the kernel, tries to load the file system, it will check the same thing for the vendor partition, system partition, and so on. And they also implemented some AB mechanism, so AB update mechanism. And in that case, they implemented the rollback protection. So if one update doesn't go right, it can go back to the previous update. So this part, however, is not supported in U-boot, for instance. The U-boot features can do some of the verification, but it cannot do like rollback, for instance. So that's it for the Android architecture. It was pretty fast. The idea wasn't to cover everything, because there are like a full presentation about the architecture. You can look it up, like on the last ELC Europe. Sergio Prado did a good presentation about the differences between Linux and Android. In the last live embedded event, there was also a good presentation from Pierre Fischer in French about that. So I didn't want to cover. I just want to give you an overview. And so now let's have a look at Android in embedded projects, and especially like the pros and cons. And before getting into it, those opinions are my own, and I'm just trying to be partial here and I mean, to be fair and yeah, see the way, explain it the way I see it. So the main pro, I would say, is for app development, and that's the obvious answer. For many reasons. First of all, there is a great separation between BSP and app development. For app development, Google provides the SDK for Java and Kotlin, and the NDK for C, C++ native build. But they also provide a lot of tools, Android Studio being the main one. You can see a screenshot on the right, where it allows you to easily make your application, easily design it as well. So there is a designer inside, and easily debug, because you can seamlessly debug Java and native in the same run. You also have some an emulator available. So for instance, if you don't have the hardware ready for your project, a developer could start developing the UI on the emulator, because it would work exactly the same in the end product. And also, all those tools are working on every OS, whether it is Linux, Windows, and Mac OS. It works great. And I know the other Linux projects also have SDK support, like Yocto can provide you an SDK, Beardwood can provide you an SDK, but to be completely honest, it doesn't give you the same feel as the full solution from Android, in my opinion. And also, like, the fact that it can work on any OS is a big plus. So there are also like some proprietary solutions, like Qt, for instance, that provide their own IDE and their own toolchain where you can develop as well. But yeah, once again, it feels to me that this is the best solution for app development, the easiest at least. And they also provide a lot of tools. So as I said, like, so Android Studio, you can debug there, and you can debug over USB or wirelessly thanks to ADB. And there is also a lot of profiling tools that you can use. And when it goes to app development, it's not just only the fact that there is the SDK that is good and good tools. It's also because there are like a lot of different resources. So it goes from the actual documentation from Google, which is very exhaustive and it's very well written, but also the fact that you can have many examples. Like, for instance, if you want try to connect to a Wi-Fi access point, and you're wondering like, oh, how do I scan for Wi-Fi access points and everything? Like, you type that in Google, you say Android scan Wi-Fi, and you will find hundreds of different examples of that. And that is what's great about it. It's that you can find an example of pretty much any API, and that API is common across all the Android devices. So if you do that work on one device, doing it on another it's just going to be the same. There are also like some open source projects that I wanted to talk about, like the F-Droid, which is a great example of an open source project for Android, where it gives you an app store, an open source app store, when you can actually rebuild it yourself and make it for your own company. Like, you can build your own server and your own client, so that, for instance, if you ship a product, you could have your own app store and only push apps that you agree to serve on those platforms. And finally, it's easy to find developers. It's easy to find developers to do that work. You know, if you look up on whatever website, HR website for an Android developer, you're gonna find hundreds of them. So that is the main pro, in my opinion. Now the cons. Let's be honest, the BSP development is part of that. There are several reasons. The first one, in my opinion, is that it's really dependent on the silicon vendor support. So depending on the SoC that you're going to use, you might not even get any Android BSP. Some vendors don't even provide it. And sometimes you might get a BSP, but not very complete, like not having like everything included, like not all the codecs and so on. So it's really dependent on that. And so that might just end the discussion here. Like, for instance, if you use a vendor that doesn't provide an Android BSP, don't try to create that BSP on your own. Not that it's not possible, but it would take just a huge amount of time it would take too much time, in my opinion, to be worth it. Then now, let's say your silicon vendor do provide Android BSP. Many people are scared when they see the source code itself, because it's huge. It's about like 100 gig of data. It has like hundreds of projects, and so people get lost into that source code. And so so that's also a bit of a roadblock for some people. And to overcome that, I mean, what I do most of the time, like when you get lost in the OS, for instance, you have a problem, you don't know what it is, and you look at the logcat and you see a class that throws an error. What I use a lot is the online xref, where you can just look for the message that you see or the class that you see that's throwing an error, and it will give you where it is. And it is very, very useful. And I know, like, after sharing that information to some customer, they were feeling more confident that they could find where they would need to look into when they were having issues. So strongly recommend using that if you want to start messing around with the source code. Then, opposite to the app side, also the documentation is not as good as on the application side. But Google is trying to make it better, definitely. Like, it came a long way from what it used to be. Like, there used to be no documentation about the BSP development, basically. And now there is a lot of concepts that are explained. You can see on the right side, like, what it looks like, for instance, when they explain the hardware abstraction layer. But the thing is that, you know, the BSP work is very like platform. There are some parts that are platform specific, so it's hard anyway for them to have like a good documentation that would fit like all the different platforms. And for that reason, not many people got into BSP development for Android, and so it's hard to find developers that are good at that. It's much harder to find a PSP Android developer than an application developer, definitely. And then the last question is, how do you maintain your code base? How do you update your system? Like we're talking about embedded projects here, so it's supposed to run for like 5-10 years. How do you update in 5 years and so on? So to answer that that issue, Google has been trying to create some new projects. So the project Treble was the perfect illustration of that. Like they tried to make it easier for people to upgrade their Android version. So the project Treble basically is that the way it used to work, like you were doing your hardware abstraction layer, but then the next version, Android would add something to the hardware abstraction layer, so you would have to rebuild it or at least modify it a bit. And since some of those hardware abstraction layer are binary blobs from the vendor, you would get stuck, because basically, like if it's a blob, you cannot modify it. And if the vendor doesn't provide a newer version, you would get stuck in that old version. Now, the way it works with Idle is that when you have your own hardware abstraction layer, you can say, okay, so this works, like this is a version 1.0 of that hardware abstraction layer. And so that way, like when you upgrade the OS, you can tell the OS, okay, so I still have that binary from 2 versions before, and FYI, it's only working, it's only like a 1.0 binary. And so in that case, the OS will know that it's missing some of the features and so on, but it should be able to work on with it. So it started, I think, between 8 and 9. It wasn't completely working at the time, but like I've tried it between 10 and 11, and it went very smoothly to be able to say, okay, I'm using some hardware abstraction layer from the previous version, and it went fine. So really a good example of what Google is trying to do, but it's going to take still some time for people to realize that. Then another big issue that often comes up is the resources requirements, because as we said, like the source code is huge, and there is a reason for that. There's like many different features in there, and so many different services running. So I did an example where if you run Android 10, by default, you're going to have like 1 gig of RAM at boot up that is used. So if your plan was to have like only 1 gig of RAM on your system, well, I don't recommend using Android. End of the story. Because there's just too many services. And then the question comes like, oh, but can I remove the services I don't need? Anything is possible. So I could say yes, but I would say no at the end, because when you remove the services, some other services can rely on others. Like for instance, like even if you don't use the phone, you need to have the phone service there, because the entire API is relying on it. And also, like if you remove services, you could get some crashes when like writing your application, because the SDK provided by Google expects like everything to be running underneath. So I would say that's problem number one. The thing is, though, is that now like platform ship with more and more memory, so it might not be that much of an issue, but still, it's still a lot compared to what you could get on Linux. And the same goes for the storage. Definitely, I mean, I put at least 4 gig, but I could even bump it up to 8 gig, because since there are like so many partitions, as we talked about, yeah, it's using at least 4 gig just for the system itself. And so if you want to have some space for your application and so on, I would say 8 gig is the minimum. And then hardware abstraction layer. So here, what I wanted to say is that it's pros and cons, because it's great when a vendor of a specific chip do provide the hardware abstraction layer. That's awesome. So on the right side, you can see I did integrate a 4G modem from Quectel on our build. So this is a 4G MPCIe module that you just plug into your platform. And so Quacktail provided the hardware abstraction layer, and like in a couple of hours, I was able to get a 4G connection, and everything was working out of the box, especially since Google also provide like a list of APNs, so I didn't have to configure anything. It recognized my SIM card. I was able to browse the internet over 4G. So this part is great, you know, like when it's working, it's awesome. And also in that case, you know, I interfaced properly with the OS, so anyone from their application would use an API that has for the SIM card status or the signal strength or what network we're on. Everything is working out of the box. However, the problem comes where if the vendor doesn't provide a hardware abstraction layer, it can be very, very painful. So that's also can be a roadblock. At the end, it depends on which sensor, I mean, which chip we're talking about and which hardware abstraction layer we're talking about. For instance, for the 4G modem, I don't think I would go on my own, create my own hardware abstraction layer if the vendor wouldn't provide it. But I'm okay doing that, for instance, for a sensor, like for an accelerometer. There are some like generic hardware abstraction layer, like the IIO sensor hardware abstraction layer, which would work with any IIO sensor. So if a customer says, oh, I want to use Android, but I want to use this accelerometer, and there is no Android support, but if the sensor shows up as like a regular IIO device from the kernel, I'm okay. You know, that's okay. So it really depends on which hardware abstraction layer we're talking about, but you have to be careful about that. And also here I was talking about accelerometer or 4G modem, and that's great because the hardware abstraction layer is there already. But what happens when there is no hardware abstraction layer for a specific interface that you want to use? For instance, I always get the same questions like, oh, I want to talk to an I2C device from my app. How do I do that? Serial, UART, SPI, and so on. How do I do that? So this is in the cons list. So now that we've seen some pros and cons, I wanted to answer some of the frequently asked questions from my customers. And there is no specific order. Sorry in advance. It's not very solid. I just like everything that came to mind as a question, I put it in there and try to answer it. And as I was saying before, like the first question I get is how to access the hardware. Like, what is I want to blink an LED, which is the example you can see here. Like, how do I do that from my application? And so there is the easy way and the good way. I'm going to start with the easy way, which is to actually access your LED from your application. So you can see an example here. But this way is actually requires to do some work to be able to work properly. And so one of the first things you need to do is that you need to make sure that your the node that you're trying to access has the proper permissions. And so here I show an example on how to update the uevnd file to say, okay, for the LED, make sure that you get read-write access for user and group as system and system. And so the recommendation here is to never give, or at least, never give access to others. That would be the main recommendation, which is going to bring another question, but it's gonna be at the end. And so FYI about the uevnd, it's the same. It's another good example of what Google redid. Like Android isn't using udev or mdev. It's using its own uevnd daemon, and yeah, so it's using uevnd RC files to know like how to give permission to some nodes. So here, from that previous example where I tried to access the LEDs, here I say, okay, for all the LEDs, I want the brightness node to be read-write accessible for system. Also, you need to update the SC policies, SC Linux policies, because with SC Linux enabled, it's not gonna like you trying to access nodes directly. So you also need to do that, to update that. And finally, here you can see that I give the node access only to system. So what I did here for this specific example is that I gave the system UID to my application, which is not a perfect way, let's be honest. In my opinion, it's better to, if you're sure that, you know, like you only have one application running, which is the case for many embedded application, it's better to make it a system UID and limit the access to everything to system and not give permission to others than trying to give like others permissions and not have your application as a system. So this is, once again, this is the easy way. And the reason, once again, is like I wouldn't advise that for like a full-blown, I mean, you couldn't pass the Google certification anyway if you start having like many different application as system UID. But if you do just your own embedded project with one application, I mean, I can live with that. And that's why here you can find some GNI examples of how to access GPIOs, I2C, and serial as well, because those were the common requests. And then like, so when we're telling customer, okay, so if you really have like one application and you want to access the I2C, so here's an example, and you need to sign, you need to be a system user ID. And to do that, you need to sign with the platform keys. And so usually the customer says, okay, yeah, but we want to use Android Studio, and no worries, Android Studio can sign your application with any key you want. So you can still use Android Studio, sign it with your platform keys, push it on your device, debug it, and so on, and it will work just fine. So that was the easy way. Now the proper way to do that would be to create your own custom hardware abstraction layer. So you can see like a graph on the right side from Karim Yagmo from his book, The Embedded Android, which I highly recommend. So when you do that, you can either be as part of the system server or a standalone service. And the good thing about that is that you can create a SDK add-on, and that's also something that I love about the overall like app development experience, is that if you want to do it that proper way, you can still give an add-on to the SDK, so people can use the regular Android SDK. You don't modify that. You just give an add-on to the customer, and then they can start using your own custom services. So, for instance, you could do that to access GPIOs or I2C. The AOSP provides some library, which is a good start to look into. And there is also the basic service and basic client that I did a long time ago. So it doesn't, like, it's very, very, very old now. I think it was in 2015, but it should still work. It just doesn't have any idle versioning or whatever, but it gives you the idea on how to have like your own service. That's going to be system UID anyway, and then expose it through like a regular like binder interface to all the application and providing an add-on to the customers. So how to sign your app or your build. So for the app, we've seen like how to do it on the on Android Studio, but you can sign, like, you have to sign the entire build when you do your own package at the end, especially for OTA updates. So when you want to do OTA updates, you have to run like make OTA package, and that will sign the entire thing with your keys. It's using some default keys that are, so I give you the link to the default keys, but you can override that obviously to use your own keys. And so the reason I'm talking about that is that if you see, like, if you want to use some APIs that are marked as not used by third-party applications, like you can see at the bottom, it means that you need to sign with the platform keys, just like we did here, where we signed with the platform keys, the application to be able to access system UID. Here, you also need to sign with platform keys to be able to access some specific API. So here, the reboot API. So it makes sense because you don't want any application to force a reboot on your platform. And so the platform keys basically should only be owned by you and only you. So now quick slides about how to do OTAs. There was like two different way to do OTAs in Android. The old one, which is the non-AB system update, the way it worked is that you would have a client on the platform that would download or you push to your platform the update, and then that client would verify that the update is properly signed, and then reboot into the recovery console, install it, and reboot again. So that is the old way of updating the kernel, the OS, and everything is provided. So the entire API is provided, but there was no client implementation. So here I give you like the FSL OTA, which was written by Freescale and XP. It's a good example to get started on how to get the package from the HTTP server and verify it and reboot it, and then it works. So once again, it depends if whether you use AB or non-AB system on your BSP. So yeah. Then how to do OTA with AB. The goal of the AB, like why they switch from non-AB to AB, is that AB, as the name suggests, is that you have like two different partitions every time. Like for instance, you have two system partition, two vendor partition, two boot partition. And so if you're running on partition A, while the system is running, while you're using your embedded device, the daemon is gonna get, verify, and flash the B partition. So get, verify the package and flash it on the B partition. And then if everything works fine, it's going to reboot, telling the customer, oh, I just flashed the B partition, try to boot from it. And at this point, the bootloader will count like how many times it tries to boot that new B partition. And if it doesn't succeed, it can roll back to the A partition. So in this case, actually, Google provided the daemon that you can use to do that, which is the system updater sample. And it just downloads from the HTTP server and does the update. So that's a great example and a good starting point. How to start a native service? Sometimes people want to have a script run at boot. And so here I give you an example on how to do that. Basically, you have in the init.rc, you have triggers, you have action and services. And so the action have triggers, so you can do on a specific trigger. So either like, oh, if I'm booted completely, or if this property is set, do this or do that. And then you declare your service, and the service has like different many parameters. You can select its user, its group. You can select whether it is critical or not. So when it's critical, if it dies for any reason, the OS will restart it. If it's not, if it's a one shot, if it dies, and doesn't get restarted unless you start again, and so on. So this is a good example. Sorry, I'm going a bit faster because I want to get to the demo at the end. How to have only one app running. There's like two different ways. I see the old one, which was to create like basically like your own launcher, because when your application reply to the home intent, it can replace the launcher. So you can have your application showed up instead of the launcher. But when you do that, you still have the system UI that can overlay that launcher. So you can still have the navigation bar or status bar showing up, and the drawers and stuff like that. You can overcome that by disabling all of that in the build, like by customizing the build. But the new way and preferred way to actually have only one app running is to use the lock task mode. which requires to have like a device policy controller. I'm going to give you an example at the end. And the way it works is that when that device policy controller starts and say, hey, here is the kiosk app that I want to use, and I don't want to be anything to intervene when it's running. So I don't want to be able to exit to go to the settings. I don't want to see the navigation bar and so on. Like that does it automatically for you. So then how to customize the build? As I said, like I give you like 2 examples here on how to customize the UI. So there is like some XML files that you can find in framework base usually, where you can select the way you want to see things. So you can say, oh, I do want or I do not want a navigation bar. A trick to get rid of the status bar is to set it aside to 0. In that case, there is going to be no status bar. Then another most common request is how to add specific APKs or specific applications to a build. So for that, I invite you to look into the makefile inside your device folder, and you will see that you have product packages where you can define the packages you want to be included in your build. There is also like product copy files where you simply copy files from one source to a destination. And you can also like have your own recipe of sorts, your own makefile that says, okay, I want to copy a pre-built APK, but I want it to be signed with a platform key. So there is an example here. Oh yeah, going back to the XML, try not to, and even in general, try not to modify Android core or Android frameworks. Like the build system gives you overlays and gives you many things to do that without modifying it. And so try as much as possible to not modify the core, because it will help you in the long run when you try to update from one version to another. If you haven't if you've done everything outside of the core, it's going to be much easier to update than otherwise. Also, sometimes I get some security questions, and so I wanted to give like quick guidelines. And it's gonna sound obvious for many of you, but trust me, like many people don't do that, and I just want to make sure that everybody does. First thing first is for your chain of trust is to enable the secure boot. Have SE Linux as enforcing, not permissive. Only ship user builds, not user debug. You don't want people to be able to use SUE and stuff like that. Use your own signing keys, because if you use the default signing keys, everybody has access to it. Update your kernel. So there is a great talk from Greg Kroatman about that. I mean, it's getting easier and easier to integrate kernel stable releases. So just do it, especially since now every stable release goes for like 4 years. So go do that. And if possible, also integrate the Android security patches. Also, sometimes people don't want to deal with everything, but they want to use those Android features. I wanted to show like the different solutions from two partners of ours. Kinetics, which gives like a very nice OTA management called Update Factory that can easily help you like maintain and update your platforms. They also provide some low-level SDK add-ons to do GPIO, I2C, and so on. Just like I did the easy way, they do it the proper way. They can do build customization, and Esper.io also can help you with the fleet management, so setting the device policies and monitoring your device in real time and so on. So those are two third parties that I would recommend if you want to go with the Android on your embedded device. So now, real life example, and I'm gonna go quick because I want to do the demo. Case study number 1 is our access control device. So at Boundary Devices, we have an access control device which is used in many stadiums in the US to control access to some VIP rooms and stuff like that. The features of that is that it's a 7-inch display, barcode scanner, NFC for the tickets, and Weekend protocol to control the locks of the door. Why Android? Because there was already a project. There was already a project using an Android application from a very old Android build, and we took that whole thing because the customer wanted to have the same features as the previous one, and it only took like a few days to adapt it to our platform and get it running. And so the customer was very happy to be able to use the same thing, just with newer and better hardware. And so we use the app in kiosk mode, and we have all the security feature I talked about enabled. And also like recently, so we had that with a iDynamics 6 platform, and we really recently like switched to iDynamics LM Mini. So we switched from Android 8 to Android 10, and we switched the CPU, and adapting the application only took a couple of hours. And mainly it was changing the GPIO numbers and the SC Linux rules, and that was it. So just to show you like how powerful it can be to once you have developed your application with Android, following the SDK as much as possible to just have the same thing working on another device and even another CPU. Second use case was for some digital signage. So I cannot tell the customer's name or exactly what it's doing, but why Android basically was for HTML5 application. And so it needed to have like some good browser experience with all the acceleration, video, and graphics. And maybe it's only me who had bad experience with Linux in that field, but there was a lot of there's always a lot of issues having the browser properly working. Like if you try to build Chromium, there is always something missing. Whereas if you use Android, since it uses the base API to do all of that, if your vendor supports graphics and video acceleration, the browser will support it too, and it's just gonna work. And finally, we did a reg tablet. And here, like really, why Android? I mean, it made sense. It provided the customer with a well-known UI, and we were able to do a custom app store, and we had a device owner and manager in place to be able to limit the functionalities and stuff like that of the tablet. So really for industrials. So let's have a look at the demo now. Sorry, I'm running a little bit of time out of time. Let me try to share my screen this time. Oh, sorry. All right. So let's. I should have the application running already. Okay, there we go. Do you see? I hope everybody sees it. So here, what I did is that I did very simple application. So obviously, I'm not an application developer. I did a very simple application which just goes full screen. But as you can see here, if you just do an application that goes full screen and you scroll back down, you will have the drawer showing up. You will have the navigation bar and the status bar here. And so the goal here, so if I exit that, the goal, what I wanted to show you guys is that if I install a device owner, then I should be able to switch into kiosk mode. So here it says that I'm not yet a device owner, which is fine. Let's do this. All right, so here I've set the device owner to my application. All of the applications are available online. Sorry, I have two mouse, so. And so now, if I start the device owner, okay. See, I can start the log task mode, and if I do that, you will see my app restarted. And now, like if I try, you can see that the status bar is empty, and you can even see that the navigation bar only has the back button to be able to go back. So here, see, I can browse the web. And this is also a good example. Like here, it only took me like 30 minutes to get that app running, you know, and it's browsing the web. Everything is accelerated and so on. So yeah, so that's what I wanted to show you, like how a full screen application on an Android device could look like, and how to use it on your device. So sorry, it was a bit a rush at the end, but I wanted to show you that demo. Here are the references, and I wanted to. So I have 3 minutes left for Q&A sessions. So let me know if you have any questions. Let me check Slack. I haven't checked Slack. Okay. Thank you, Christophe, for sharing Pierre Fischer's presentation. Also, yeah, Mathieu, thanks. That was exactly Sergio Prado. So all of those are part of my reference section here. You can see that I do give a link to Sergio's presentation about Android versus Linux, and Pierre as well. And obviously at the top, Karim Yagmour book. So I would like to hear your insights for AOSP use in automotive industry. 5 years from now, will we see more AOSP, Linux, or AOSP plus Linux for, say, infotainment system? Well, I'm not really in the automotive field, but what I've seen definitely is there's a lot of interest in Android Auto right now. So yes, definitely, I see a lot of traction there, and I see it getting big within the next year, whether it is AOSP, full Android, AOSP plus Linux, and so on. I don't know, but definitely it's going there. Like everybody is pushing towards Android Auto. Any other questions? All right, so the slides will be available. Once again, I was a bit quick on some of the aspects, but I hope that, you know, if you go through the slides again, you will see where everything fits together, and hopefully I gave you some insight as to like how to use your Android in your embedded application. And once again, like on the demo, I mean, it was really like a very simple demo, but everything is available on GitHub if you want to start your own full screen application and start your own logs task and stuff like that. Everything is available. Feel free to send me an email. All right, so it's 1 hour. I have to log out now. Thank you very much, and hope to hear about you. Bye.